So let's go back to this example. You can put this in your notes, and which variable should we put on the horizontal axis?
Liters of NaOH.
And on the vertical axis?
pH.
All right. So let's figure out what the vertical intercept should be.
HCl, it should be 1.
I'm sorry?
It should be 1.
pH of 1?
Uh-huh.
Yeah, and how did you get that?
Just calculated it
Yeah,
earlier.
this is the example we've done before. So we have 0.1 molar HCl. This is going to produce we're going to end up with 0.1 molar of hydronium. We already worked that out earlier. And then the pH would be the negative log of 0.1, which is 1. That was the case of a strong acid by itself that we've already learned how to do. Now let's say we add 30 milliliters sodium hydroxide. And now we want to find the pH. So let's try working that out. And we'll try to use the same kinds of approaches and notations that we used before, although there might be some new issues here. Okay, let's talk about this together. You get off to the right start there. The chemical equation here is different than before. Who are the two things that are going to react with each other? The acid and the base. So there's no point showing the acid here reacting with water, because who would you rather react with? Water or a strong base? You'd rather react with each other. So we're going to write this as hydrochloric plus sodium hydroxide. What are going to be the products?
H2O and NaCl.
Good. So let's keep working through that. Okay, maybe we should talk about this together a little. I think you've seen that one of the key issues here is it's no longer convenient to work with, well, yeah, how should we?
You have to change it from,
We have to change into moles.
yeah.
You have to change into moles because this concentration will change when we dilute it.
Okay.
Since we're adding more water, we're going to be diluting this, so we can't just put in 0.1 molar hydrochloric in this case. All right, so how do we figure out how many moles of hydrochloric we started with? Well, we have 0.1 moles of hydrochloric per liter. And how many liters do we have? 0.1 liters. 100 milliliters is 0.1 liters. Am I doing this right? So I'm getting 0.02 moles hydrochloric. All right. Nope, I did that wrong. I should get 0.01 moles.
Yeah.
And you were able to do that to 0.1 molar is the same as 0.1 mole.
Yeah, let's see how we did that. So we know that we're starting here with 0.1 molar hydrochloric. Now what does capital M stand for?
Molarity.
Molarity.
And what does that stand for?
Moles per liter.
Moles per liter. So this is the same as this. So 0.1 molar doesn't mean 0.1 moles. It means 0.1 moles per liter. And then I'm multiplying by the actual number of liters we have, which is 0.1 liters. It's like a unit conversion. And when we do the unit conversion, we end up with 0.01 moles. So notice that the moles was not the same as the molarity. The moles was not the same as the molarity because we didn't have 1 liter. Okay? And then we have to do the same thing to figure out how many moles of sodium hydroxide we're dealing with. So how many moles of sodium hydroxide do we have here?
0.003.
We have 0.1 moles sodium hydroxide per liter, 0.1 molar sodium hydroxide times 0.03 liters. So it looks like you're right, 0.003 moles sodium hydroxide. So that is a good number to now put in here, or now we can make everything into concentrations now. Should we put things into concentrations?
You can just, it'd be 130 milliliters.
We might as well put things into concentrations because that's how we're going to calculate the answer. So what's our volume here? 130 milliliters, or 0.13 liters. What did you get for those molarities? 7.023.
Yeah.
Okay. So the starting amount of hydrochloric is 0.077, and the starting amount of the sodium hydroxide is 0.023. Now, is this reaction going to go to equilibrium, or is it going to go to completion?
Completion.
Completion, so we don't put x's in this equation. Since we're going to completion, we know how much we're going to use up. Who's the limiting reagent here?
NaOH.
NaOH.
So this is how much we're going to use up, just like you had written down. So that was good. Remember that if you go to completion, you need the limiting reagent approach. And if you go to equilibrium, you use the Ka approach. Now, we don't care what the concentration of the water is going to be. And remember that sodium and chloride are unreactive, so we don't care about those concentrations either. Chloride is unreactive because it's the conjugate of a strong acid, and sodium we've seen as a spectator ion that doesn't participate in these reactions. So I'm only going to bother writing down these concentrations. It might seem weird not to write down any product concentrations, but that's really the best way to deal with this.